All right, before we start, I need to point out a typo on your worksheet. This number here, whoops, sorry about that. This number right there should be 430 million. You need to add some more zeros on there. Okay, now once that's done, let's start talking about scientific notation. Scientific notation is a shortcut, a shorthand way of writing very large and very small numbers. Okay, mathematicians, scientists, sometimes we get lazy. We don't want to write all those zeros. So somebody came up with this shortcut. In scientific notation, what you're doing is you're going to take your number that's written in standard notation, the regular way we write numbers, and we're going to rewrite it as a multiplication problem with two factors. The first factor has to be a number between 1 and 10, and the second factor is a power of 10, so 10 with some exponent. Now, how do you decide how to write those factors? Well, your first factor has to be between 1 and 10. So you look at your number, 430 million, and you place the decimal where it needs to be, so we have a number between 1 and 10. So in this case, we're going to place the decimal between the 4 and the 3, 4.3. Our first factor will be 4.3. And then what exponent should we use? Well, remember, hopefully you figured out that when we multiply by 10, the decimal place moves 1 to the right. So we have to figure out what power of 10 are we multiplying by to get the decimal all the way to the end, because that's where the decimal would be in our number, 430 million. So how many times does that decimal point move? It moves 1, 2, 3, 4, 5, 6, 7, 8 times. That means we multiplied by 10 to the 8th. Our exponent would need to be 8. Okay? If we have a very small number, 0.000057, okay, we still need to place the decimal point so that we have our first factors between 1 and 10. So we would put the decimal point right between the 5 and the 7. And then how many times would we have to move the decimal to the left? How many times would we be dividing by 10? Okay, well, we're going to move it 1, 2, 3, 4, 5, 6 times to get that decimal point back to where it's supposed to be. And we moved to the left. We divided by 10. And remember, negative exponents are dividing by 10. So our exponent would be 10 to the negative 6 in that case. So a lot of things going on here, a lot of ideas that you have to put all together. Okay, so first of all, how do we know if our exponent should be positive or negative? Well, that's really not so hard. A positive integer as an exponent is going to make our number get bigger. We're multiplying by 10 to the 8th, some factor of 10, the number is going to be bigger. So if you have a big number, like, if you have a big number like 430 million, you're going to have a positive exponent on your 10. If you have a very small number, 0.000057, we're going to have a negative exponent. We're dividing. We've been dividing to get something that's small. Another thing to think about, something that's very cool. Think about your number line. Positive integers on your number line, where are they? They're to the right. Which way does your decimal point move in scientific notation if you have a positive exponent? Boom, it moves to the right. Positive integers are on the right. Negative integers on your number line. Negatives are where? They're to the left. Okay, so what direction do I have to move my decimal if I have a negative exponent? Boom, 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 to the left. How cool is that? Everything works all together. It's great. Math is a wonderful thing. Let's take a look now. Let's think about how to go from scientific notation to standard notation. How do we think about that? So if I have 4.3 times 10 to the 8th in scientific notation, and I need to rewrite it into standard notation, if I want to go that direction. Well, we're going to start at our decimal point. Scientific notation is all about the decimal point. We're going to start at the decimal point, and the exponent will tell us how many spaces to move the decimal point and in what direction. We have a positive exponent. Positives are to the right. Positive exponent is going to make your number bigger. Okay, so we're going to move to the right. We need to make the number bigger. So we would move to the right 8 places. 1, 2, 3, 4, 5, 6, 7, 8. And then you're going to have to add your zeros into those spaces. All right. If we had 5.7 times 10 to the negative 6, and I ask you to write that in scientific notation, you're going to start at the decimal. Your exponent is negative 6. Negative exponents are dividing. They make our numbers smaller. We need to move to the left. We would move to the left 6 places. 1, 2, 3, 4, 5, 6. And then you're going to need to fill in some zeros. Notice how many zeros you fill in. 5 zeros when the exponent was negative 6. Again, something very cool. All right, so that's the basic idea. Now we need to start doing some practice. All right, so you got to think about what's going to be happening here with your information. If I'm starting in scientific notation and you need to write in standard notation, that means the way that we normally write numbers, you want to look in, first thing you want to ask yourself, is the exponent positive or negative? Because that tells you which direction to move your decimal point. All right, so we have a positive exponent in this first problem. A positive exponent tells us to move in which direction? Positive numbers are to the right on the number line. We need to make this number bigger. We're multiplying by a positive. So we're going to move to the right. We're going to move to the right, and how many decimal places will we move? Or how many places will we move? We're going to move 6 places because the exponent is 6. So write the number in standard notation. Take your decimal point, move it 6 places to the right. 1, 2, 3, 4, 5, 6. Whoops. So we've got 4, 1, 2. We need 4 more zeros. So what is our number? 4,120,000. 3.4 times 10 to the negative 5. Is the exponent positive or negative? It's negative. So which direction are we going to move? Negatives are in the left on the number line. We're going to move left. And how many spaces? 5 spaces. So we take our decimal point, we move it 5 spaces. 1, 2, 3, 4, 5. That means we've got a 3, 4, and then we have 4 more zeros in there. And you can double check yourself. Go back 5 spaces. 1, 2, 3, 4, 5. Yep, that was it. All right, that's the basic idea. All right, here we go. Let's do some more. Always ask yourself, before you start, which way should I be moving the decimal, and how do you know? You know because of the exponent, if the exponent is positive or negative. So, problem number 3, positive exponent. We're going to move to the right. We're going to move to the right 5 spaces. So right now we have 8 point, like that. The decimal point's right there. We're going to move it 5 spaces. 1, 2, 3, 4, 5. We're going to fill in some zeros. So the final answer is 800,000. All right, we'll do number 4 together. I'll leave number 5 for you to do on your own. Number 4, we have a negative exponent. That means our decimal is going to move to the left. It's going to move to the left 4 spaces. So 1, 2, 3, 4. We're going to have to put 3 zeros in there. All right, so I've got a 7 and a 1. I need 3 more zeros. I've got a decimal point. Okay, go ahead and do 5 on your own. All right, so up top here we have a review of how to convert scientific notation, how to write in scientific notation. So we need to have our first factor be a number between 1 and 10. So problem number 6, we're writing in scientific notation. Problem number 6, my first factor is going to be 3.2. Place the decimal point so that your number is between 1 and 10. Now, from its location in the first factor, 3.2, which way must the decimal move? I'm trying to make the number bigger. I need 32 million. So, what direction is my decimal point going to have to move? It's going to have to move to the right. And how many places? If I'm at 3.2 and I need my final answer, how many places am I going to move? 1, 2, 3, 4, 5. Uh-oh, I lost track. 6. 1, 2, 3, 4, 5, 6, 7. Whew! 7 places. I'm going to move to the right 7 places. If I'm moving to the right, is my exponent positive or negative? It's positive. That's right. So our final number in scientific notation is 3.2 times 10 to the 7th power. Notice how many zeros were in standard notation. And notice the power. It's 7. Interesting. All right, second problem, number 7. Place the decimal point. Place the decimal point so that you have a number between 1 and 10. So I need 7.12. Okay? Now, from its location in this first factor, which way must the decimal point move? Here I am at 7.12. I need to move the decimal point to the left to get to my standard notation. I have the number 7.12 and I need a little teeny itty bitty number, 0.0000712. I need to make a small number. That means I'm moving to the left on the number line, small numbers. All right, and how many spaces to the left will I have to move? Well, let's see. I'm at 7.12. And I'm going to move 1, 2, 3, 4, 5, 6, 7, 8. 8 places to get my decimal point where it needs to be. So, in scientific notation, I have 7.12 times 10 to the 8th. Just for kicks and giggles, why don't you count those zeros? 1, 2, 3, 4, 5, 6, 7 zeros. Huh. My exponent is, oh, Lord have mercy, negative 8. Thank you for catching that. The exponent's negative 8. Interesting relationship. All right, again, before you sit down to do some problems, think about, should my exponent be positive or negative? How do you know? All right, we're going to write each number in scientific notation. We're going to start by writing the first factor as a number between 1 and 10, 4.1. So 4.1, then let's figure out times 10. Is your exponent going to be positive or negative? That's right, it's going to be positive because we are moving to the right. We're making it bigger. How many spaces to the right? 1, 2, 3, 4, 5, 6, 7. You had to move 7 places to the right. 10 to the 7th. Again, notice how many zeros are in that number. Interesting. All right, here we go. First factor, 6.43 times 10. Is my exponent going to be positive or negative? That's right, the exponent's going to be negative. I'm going to move to the left. Here we go. How many spaces? 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the negative 8. Go ahead, count those zeros, I dare you. 1, 2, 3, 4, 5, 6, 7 zeros to the right of the decimal. All right, go ahead, you try number 10 on your own.